Hi, thank you. It's my first time in this conference. It's been very stimulating so far. So today I'll tell you about a study that we have done on the editorial and peer review outcomes at science and science advances. So elite journals in science have a profound influence over scientific discourse and careers for many reasons. They concentrate public and scientific attention on certain ideas over others. They have a strong influence on policy, and publications in these journals are heavily weighted in scientific careers, things like getting tenure, grant funding decisions, and even prizes. And these elite journals typically use a two-stage review process, an editorial review process initially, handled mainly by the editors, and then secondarily, a traditional peer review process. And roughly speaking, this is what you might call a review almost nothing model of peer review, because the editors desk reject a large fraction of all submissions that come in. And so on the screen, I've tried to describe this with a submitted group being, like 10,000 papers, for instance, for science in a year, of which only about 15 or 20% are sent to review. And then finally in that year, they might publish 6.1%. And so that editorial review process is really fundamental to the entire publication pipeline. Editorial review, unfortunately, is very under-theorized and also understudied. And elite journals themselves are very rarely studied. And this is partly because there's a profound lack of data available to do that. You typically have to partner with these journals directly in order to make a study of their internal review process. So today I'm announcing a data set that we are going to release later this year, the AAAS peer review data set. It's an anonymous data set on elite multidisciplinary peer review. It includes 110,000 submissions. These are regular articles covering all areas of science published at two elite journals, Science and Science Advances. Covers 5 years of time, so 2015 to 2020. It does not cover COVID publications. And this data is being shared with permission from AAAS. One of the stipulations of sharing it was that it would be anonymized. And so we very carefully went through and removed all personally identifiable information from all manuscript records, broke all the ties between the records so you can't link reviewers to authors, et cetera, et cetera. But in each manuscript, we include a uniform set of author and manuscript characteristics. For instance, we embed each of the manuscripts into a topic area, 1 through 10, or 1 through 30, or 1 through 100, using 3 different clustering approaches using the titles. We include all editorial decisions on each manuscript. We include information about the number of authors, like the team size, along with characteristics for the first and corresponding author, such as their institutional prestige, their gender, and their geographic region that their institution is based in. For science, they have a special board of reviewing editors that helps the editors make the initial decisions. And we include the BOR evaluations for those manuscripts. These include the score that the external evaluator gives 1 through 10, along with their confidence. For manuscripts that get sent to review, we include review characteristics such as a Z-score of the length of the review and the review sentiment, so sort of positive or negative overall, along with the reviewer gender. And then for each manuscript that gets sent for review, we include 2 randomly selected reviews from the first round of review. Papers that go through 5 or 6 rounds will be highly re-identifiable, and so we have to cut at some point, and so we standardize on just the first round of review. So this data set, as I had mentioned, will be made available upon publication of the paper, but now I'm going to tell you in the time remaining a little bit of the analysis that we did with this data set. So we're going to look at 2 specific questions. One is, what author and manuscript characteristics correlate with editorial and peer review success at these journals? And then secondarily, since the elite journals have this review almost nothing model, we want to understand something about what impact do the editors have on what gets reviewed. So if we look at the flow of manuscripts through the pipeline, you can break it into those 2 stages, editorial review and peer review. Each of those stages has its own 2 steps. So these waterfall plots show you the initial number of submissions at Science, for instance, is about 60,000 manuscripts, and the number published at the end is about 4,000. And it steps down significantly at each stage. And we find overall the editorial review is a much stronger filter on publications than peer review is. Science editors summarily reject about 1/3 of all submissions. These don't get seen by anyone except for the editors. The remaining are sent to the board of reviewing editors. But the science editors at the end of the editorial review process declined 83% without peer review. So the vast majority of papers are not actually going through peer review at all. They're only being evaluated during the editorial review stage. That's about 75% for science advances. But conditioned on being sent to peer review, your probability of acceptance at that stage is actually much higher. So the editorial review filter is much stronger than the peer review filter at these elite journals. Essentially, it goes up by about a factor of 2 if you get through the editor gate. We also find that the topic representation across the stages changes dramatically. Some topics are a grow in representation over all publications through the pipeline, whereas other topics shrink. So for instance, topic 3 is one that shrinks from not a large percentage at first to a very, very small percentage at the end, whereas topic 7 tends to grow, right? So you can see the footprint of the editors on this process of which they're sort of selecting for certain types of manuscripts and against other types of manuscripts, even at the topic level. However, the decisions of the editors are very sensitive to the advice of external experts. So for instance, if we look at the decisions at Science Magazine, the probability of being reviewed conditional on having a high score from the board of reviewing editors is very high, 82%, if you have a BOR score of 8, 9, or 10. On the other side, the probability of being sent for review if your BOR score is very low is very small. And so clearly the editors are listening to the advice of their experts on the board of reviewing editors. And similarly, at the peer review stage, here we're showing z-scores. So z_rev is the z-score of the sentiment. If that's 1 standard deviation above the mean, then the probability of acceptance is quite high. And if it's 1 standard deviation below the mean, then the probability of acceptance is quite low. So even though the editors are having a very large influence on managing this process, being the main gatekeeper of it and guiding, selecting the reviewers, et cetera, they're still very sensitive to the input of the external experts. However, the acceptance rates vary widely based on other manuscript characteristics. So for instance, if you look at the left-hand column here along topic, you can see that there are some topics at Science, those are the red dots, that are very low. That's topic 3, 1.7% acceptance rate for manuscripts in that topic versus 9.6 acceptance rate for papers in topic 7. So that's a factor of almost 6 difference in terms of the acceptance. We find the largest signal is actually prestige. So manuscripts that are from corresponding authors in the top prestige bin, these are institutions that you can name worldwide. They're the elite institutions. They have a substantial advantage over manuscripts that have corresponding authors from the lowest prestige bins. Also, larger teams do better than smaller teams. Authors based in US or Canada do better than authors based in China. And men corresponding authors do slightly better than women corresponding authors. Now, the correlates of success, all of these things are correlated with each other. And so in order to understand their relative contribution, we need to do some untangling. Here, we're going to do it with the multivariable logistic regression. The reference group is in the braces for each of these categories. What we find is strong net associations for prestige, geography, and team size. Essentially, higher prestige is better, being based in China is lower, and larger team size is better. And very small net associations for anything associated with gender, either the authors or the editor. We find very similar effects at Science Advances, and I realized when I was reviewing my slides that the regression results on the right are for Science Advances. I thought they were for Science, and that shows you how similar the results are between the two journals. This is a nice point because it shows that Science Advances, which has academic editors, and Science, which has professional editors, have essentially very similar kinds of sensitivities to manuscript and author characteristics, suggesting that there's not really a substantive difference in terms of the types of decisions that professional versus academic editors make. Gender does change significantly over the course of the evaluation pipeline. We see a shrinking share of women corresponding authors. It goes from 21% to 18% in Science, so just a small decrease, but it is sort of systematic. And in Science Advances from 22% to 20%. There's a small association with success at editorial review and at peer review according to gender, but it's the smallest of all the effects that we measured, all the associations, excuse me, I forget my audience. And there's no parallel associations for first author, which suggests that there's something more going on here than just a sort of a classic gender discrimination effect. We think this might be consistent with an unmodeled seniority association as a result of the fact that among the most senior authors, there's a prevalence of men as opposed to women. So it could be a reputational effect. Unfortunately, in the data, there's no variable that captures seniority, and so you can't pull that out of the data directly. So to conclude, elite journals do far more than just peer review. Editorial review is really the most central part of what they do. The editor preferences are really what drive the review almost nothing model of peer review. But the editors are very sensitive to expert opinions when solicited, so from the BOR or from the reviewers. And this multi-stage evaluation process presents many places for biases or idiosyncrasies, individual preferences from the editors and reviewers to creep in. And so if we're going to understand sort of how the sausage is made overall, we really need to consider all the pieces of the pipeline as opposed to just focusing on one or the other. And I'm happy to introduce this new AAAS peer review data set, which, as I mentioned, will be available when the paper is published, hopefully later this year, in which we find these large associations for success that come from institutional prestige, topic, team size, and geographic region, with only small associations for author gender. Most associations are stronger from the editors than from the reviewers. So the editors have stronger correlations with these factors than the reviewers do, suggesting that the reviewers are attending to the content more than the editors are. This is a rich data set. It shows that manuscript evaluation is highly complex and that really understanding how the process works requires looking at the entire process. But really, we need experiments to measure the bias and to isolate idiosyncrasies at these elite journals in order to make the process more meritocratic and reflect the values of the community. I want to acknowledge my co-authors on this paper, Sam Zhang, who's now a professor at Vermont, Nick LaBerge, who's now at the US Census, Quentin McElhenney, who's a bachelor student at Colorado, and my co-author, Daniel Larimore. Here's the title of the paper. We're happy to send you a preprint version if you'd like. And thank you very much to both the AAAS for sharing the data and for the National Science Foundation for funding this project.
Thank you very much. That was a lot of work, 100,000 articles here from the audience. Yes.
Christina Wee, Annals of Internal Medicine. Thank you for your paper. And, you know, one concern I have is that as I look at the various factors that you looked at, something that's missing, strikingly missing, is sort of the quality of the paper itself. A lot of the correlates that you identified may just be confounded, you know, by, let's say, the rigor of the science that's in the manuscript. And I wonder, you know, that wasn't actually acknowledged in your limitation. And I wondered what your thoughts you had. The other thing that I would also caution is that there is a selection bias, you know, as an editor at a journal that triages a lot of papers. You know, a lot of times the reason we don't send them for review is that they don't meet minimum standards. And we're trying to sort of protect a very scarce resource, which is our peer review process.
Yeah, precisely. Let me address the question about quality, which is an excellent question. The only measure of quality that we as a community have is peer review, is the opinion of experts. There's no variable in the data set that you can assign that is the actual quality other than the opinions of the reviewers. And so I think that trying to understand what are the covariates that shape the opinion that you get, for instance, when you solicit reviews. As an editor myself, when I invite reviewers to look at a paper, I'm thinking, I have a mental model of what kinds of things I think or want them to tell me about that manuscript. And so thinking about the reviewer pool and how editors interact with it, sequential effects, which reviewers, are available at a given time and so on. These are all fascinating ways to try to get at that quality question, but there's no objective measure of quality except expert opinion, which is not in the data set.
Maybe I missed this, but did you account for, when you looked at, let's say, prestige of the author's institution, and do you account for what the result of the peer review was in terms of whether they liked the paper or not?
Maybe you mean like, do reviewers at elite institutions review papers differently from reviewers at non-elite institutions?
Or for example, like one of your findings was that authors from more prestigious institutions are more likely to get reviewed. But the question is, is there sort of differential quality in the papers that do get reviewed according to those factors, the correlate?
Again, if you could tell me how to evaluate the quality of a paper without asking experts to evaluate it, that would be very exciting. The exciting thing about the data set, however, is that it will be public. And so if you have specific questions you'd like to dig into, you're welcome to do that once it's available.
Thank you. At the front here. Go ahead.
Matthew Stanbrook, Canadian Medical Association Journal. Very interesting work. Do AAAS journals have a process that allows authors to appeal decisions by the editors? And if so, does your data set have information on the outcomes of those appeals?
Yes, appeals are allowed at both of these journals. There's a process. However, that data is not included in this data set because it's messy. And the way the appeals were handled changed over the course of that time period for science advances, for instance. And so after trying to figure out how we could get a clean version of that information, we gave up for this version of the data set. We do hope to be able to get more data and a cleaner signal for the appeals, because I agree that there's going to be lots of interesting questions to study there.
Thank you. Yes, sir.
So Steve Goodman, Stanford and Annals of Internal Medicine. So I'm going to follow up on Dr. Wee's comment. I was going to make the same one, so I'll
Great.
make the second one, which is a recommendation for how you do exactly what you do, which is maybe in your final sentence here, the experiment, which is to evaluate manuscripts either blinded to institution or blinded to the authors versus those that are not blinded, and to see if you get the same evaluation, because there's no way that all these factors are endogenous. The eliteness of the institution, their ability to publish in science, their ability to get funding, all these are highly, highly correlated.
Even the topic that they choose to study.
That's right. That's right. So the only way to get at it, which some people have done, is to do blinded, to some extent blinding of review, or take institution out of it. I recognize even that blinding is difficult. Sometimes you can just look at the references or look at the topic, and people in the field will know. Reviewing editors may or may not. But I do think before we talk about the bias associated with institutional prestige, we have to be relying on experiments like that.
I completely agree. And I would encourage you to email Holden Thorpe, the editor-in-chief at Science, to encourage him to endorse doing experiments at Science on this topic.
Will he publish a negative result? He said he won't.
Thank you. The lady at the back, and then online.
There's a lot of activity and interest online. So I'm going to fire up 2 or 3 quick questions. Meredith Weinhold from the Canadian Medical Association Journal wonders about the denominator, whether this is the pool of all manuscripts or just suitable manuscripts, given that many journals receive papers that aren't appropriate for their scope.
So this is all submissions
Huh?
minus those that I submitted.
Okay.
For confidentiality reasons, they didn't want to send me the reviewer information of my own reviewers. And then minus all the front material in the magazine, so like the policy forums and things like that. These are just regular articles, but any article that was received by an editor and looked at would be in this data set.
Great. Bahar Memani from Elsevier is asking if you intend to update the data on a regular or annual basis.
That's a question for Holden Thorpe.
Okay.
You can email him and encourage him to give us more data.
Gerben Turiet from the Netherlands asks, do you know what happens when an editor leaves the journal and is replaced?
That's a fascinating question. The turnover of editors at Science is relatively slow. They tend to have longer terms there. At Science Advances, which is run by academic editors, people roll off quite regularly. The editorial board has expanded dramatically. I think it's at 400 editors now. And full disclaimer, I'm a deputy editor at Science Advances. And so that is a very interesting question, as to say, how do the idiosyncrasies of individual editors sort of shape their decisions? We would love to be able to dig into that question. The data set that we're releasing does not allow you to do that.
Thanks so much.
Okay, I think we have time for 2 more. So lady at the back. Yes.
Yuling from University of Michigan. So I have 2 questions. One is more conceptualized. So have you looked into the relationship of does good quality paper, does it lead to getting good review, or does this kind of good review lead to getting acceptance? So that is number 1.
Sorry, say that.
Does like good quality paper or good paper tend to get good review? And does those kind of good review also lead to like success in acceptance, like in the journal? So this is one question. And the second question is related to your result, which is about the association between geographic region and gender with the success. I wonder what is the mechanism behind, especially this is those kind of like general science journal, because I do see many studies talking about like, for example, female scientists tend to do like female related disease problem, and this might not be like super general. This is one of the mechanism, or what other mechanism are there?
Okay, so the first question was about the quality of the papers.
Yes.
About good papers and good reviews.
Yeah.
So as I mentioned earlier, the only signal we have in the data set for the quality of the paper is the contents of the reviews. And so there's no objective measure that we can compare with the reviews themselves. So the reviews are essentially the measure of quality. The whole process is meant to evaluate the quality of the manuscript. And so to the extent that papers that have very positive reviews get published, we find a very strong association there. So if the reviewers like the paper, then that paper will tend to get published, which I think says that the process is working mostly as we would like it to, sort of at the high scale. In terms of the gender question, that's a very interesting one with the deep literature associated with it. I think a very important characteristic here, which ties in with the previous questioner's question, is that there's a selection effect here in terms of who submits to science at all. And in terms of like the questions that they're phrasing, the investigation they do, even what institution they're at. And so we know that there's a slight gender imbalance within the researcher community that is much more skewed towards men. And if that's also correlated with seniority, and senior men tend to do work that is more interesting to editors at science who are trying to publish the best science in the world, then you might imagine there being an association that doesn't have anything to do with the quality of the science directly and how that might be gendered, but rather has to do with the demographics of the population. And so I think trying to get to the bottom of this is a very important question. And we find some circumstantial evidence to suggest that it is an unmodeled seniority effect that drives that small association with gender. Just because the gender association is not consistent in the ways that you'd expect it to be if it was sexism, for instance.